Welcome back to the mind-bending quantum universe. Are you ready to step into a world where quantum computers are no longer just theoretical marvels, but are actively reshaping reality? If you think quantum computing is only for white-haired scientists scribbling cryptic formulas on blackboards all day, congratulations, you're totally wrong. Imagine this. One fine day, you're trying to book a flight, but you're trapped in a labyrinth of ever-changing ticket prices. Instead of pulling your hair out, a quantum computer could crack the optimization puzzle in an instant, scoring you a business-class seat at an economy price. Or maybe you're a gamer wondering, can quantum computing finally end lag? The good news? Quite possibly. These futuristic machines can supercharge graphics processing, create mind-blowingly realistic virtual worlds, and even make AI enemies so smart that you'll be left crying in defeat. But that's just the beginning. Quantum computing is set to revolutionize everything, from discovering life-saving drugs and optimizing global supply chains, to predicting exactly who will place a down payment on your dream house before you do. So, how exactly will quantum computing change our lives? That's what we're about to uncover in today's video. Stick around, because some of these applications might just blow your mind. And don't forget to hit that subscribe button so you never miss another brain-melting, mind-expanding video from my Wonder channel. Who knows? By the end of this video, you might just unlock the secret to becoming a quantum-powered billionaire. Why do we need quantum computers? Quantum computers are not just an advancement in computational technology, they unlock entirely new possibilities that surpass the limitations of classical computers. Leveraging fundamental quantum mechanical phenomena, such as quantum superposition, quantum entanglement, and quantum interference, quantum computers can process information with unprecedented speed and complexity. Here are some key reasons why quantum computers are essential. Solving highly complex problems. Certain scientific and technological problems require computational power that would take classical computers hundreds or even thousands of years to solve. Examples include quantum chemistry simulations, optimizing complex networks, and solving large combinatorial problems. If a classical computer takes thousands of years to break a highly secure encryption, a quantum computer could do it in seconds using Shor's algorithm, posing a revolutionary challenge to cybersecurity. Quantum system simulation. Complex molecules and materials behave according to quantum mechanics, making quantum computers a natural and much more accurate tool for simulating them. This capability could lead to breakthroughs in drug discovery, new materials, and chemical reactions. In pharmaceuticals, quantum computers can simulate how new drug molecules interact at an atomic level, significantly shortening drug development and testing processes. Optimization. In fields like logistics, supply chain management, finance, and artificial intelligence, quantum computers can efficiently find optimal solutions in vast search spaces. Imagine you're running a delivery company. A quantum computer could calculate the shortest route to deliver packages to hundreds of locations, significantly reducing time and costs. Practical applications of quantum computers. Smart traffic management. Optimizing travel routes, helping drivers avoid congestion and save time. Real-time response to unexpected road conditions, minimizing accidents and traffic jams. Medical research and drug development, accurately simulating complex molecules, accelerating drug discovery and treatment development, laying the groundwork for medical breakthroughs, potentially curing diseases previously considered untreatable. Artificial intelligence and machine learning, boosting AI training speed and handling massive data sets, enabling smarter and more efficient AI systems. This is why tech giants like Google are investing billions into quantum computing to enhance Google AI. Quantum computing can speed up financial market predictions, allowing investors to make faster and more precise decisions. Weather forecasting and climate change predictions. Scientists believe quantum computers can provide more accurate weather forecasts, even predicting climate trends years in advance. This capability enables proactive disaster management, helping reduce damage from natural disasters. Cryptography and security. Quantum computers pose a major challenge to current encryption algorithms, as they can break traditional cryptographic methods in seconds. However, they also enable the creation of new, ultra-secure encryption techniques, such as quantum key distribution, QKD. Banks and financial institutions can leverage quantum encryption to protect customer data from future cyber threats and hackers. Energy and material science. Quantum computing helps discover more efficient methods for energy production and storage. It accelerates the development of new materials, improving batteries and enabling green catalysts for chemical reactions. Quantum simulations can design high-capacity batteries with faster charging times, driving advancements in electric vehicles, EVs, and smart devices. Physics and astronomy. Quantum computing can simulate and solve complex equations in particle physics, astrophysics, and even climate modeling. It enables scientists to model cosmic phenomena such as black holes and star formation, offering deeper insights into the universe's mysteries. When classical computers were invented, they revolutionized computation, storage, and connectivity. Now the question is, can quantum computers spark a similar revolution? The answer is possibly, but the journey is filled with both challenges and immense potential. The dream of quantum computing. The idea of quantum computing may sound like science fiction, but we are gradually turning it into reality. Currently, we are in the NISQ era, noisy intermediate-scale quantum, a phase where quantum computers have tens to hundreds of qubits, yet they still struggle with errors and instability. Today's quantum machines can solve specific problems, but they haven't yet surpassed classical computers in solving broadly practical tasks. Significant breakthroughs. Several milestones indicate that we are moving closer to realizing the dream of quantum computing. D-Wave Systems, the bold pioneer. In 2007, D-Wave Systems, Canada, launched D-Wave 1, the world's first commercial quantum computer using quantum annealing technology, featuring 128 qubits. While not a universal quantum computer, it demonstrated the potential to solve combinatorial optimization problems. In 2013, D-Wave introduced D-Wave 2, upgrading to 512 qubits, significantly improving its ability to handle complex computational challenges. Companies like Volkswagen have used D-Wave's quantum computers to optimize bus routes in Lisbon, reducing travel time and fuel consumption. Google Sycamore, the quantum supremacy breakthrough. In 2019, Google made headlines with its Sycamore quantum processor, performing a complex computation in just 200 seconds, a task that would take the most powerful supercomputer at the time 10,000 years to complete. Google also partnered with NASA to explore the potential of quantum computing in artificial intelligence, AI, and machine learning, ML, applications. Sycamore can simulate molecular reactions at the quantum level, accelerating the development of new drugs and advanced materials. IBM, the quest for a 1,000-qubit machine. IBM has developed quantum computers such as Eagle, 127 qubits, and is aiming for Condor, 1,000 qubits, in the coming years. Through the IBM Quantum Network, the company collaborates with industry leaders like Daimler, Mercedes-Benz, to simulate chemical molecules for the development of next-generation electric vehicle batteries. China, a challenger with impressive advances. China has made remarkable strides in quantum computing with Zhuchengji and Zhuzhang, achieving quantum supremacy in specific computational tasks. Zhuchengji can perform calculations billions of times faster than classical supercomputers. Zhuzhang, a photonic quantum computer, processes information using photons, pioneering optical quantum computing. It can solve complex combinatorial problems in seconds instead of thousands of years. The global quantum race, US, China, Europe, and Japan. Major powers are investing billions of dollars in quantum research. China leads the way with over 3,000 quantum technology patents, twice as many as the US and 3 times more than Japan, according to ValueNex. Tech giants like Microsoft, Amazon, and Intel are also heavily investing in quantum computing projects, ensuring they stay competitive in this technological revolution. Challenges and limitations. Despite significant progress, quantum computers still face major technical challenges that must be overcome. Stability. Qubits are extremely sensitive to their surroundings. Even a tiny fluctuation in temperature or electromagnetic fields can disrupt their quantum state, leading to quantum decoherence. Scientists are working on isolating qubits from external disturbances and developing more stable qubits, such as topological qubits, Microsoft's approach, which are expected to be less susceptible to noise. Quantum error correction, QEC. Unlike classical bits, qubits are prone to errors, requiring extra redundant qubits to protect a single logical qubit from noise. Currently, it takes about 1,000 physical qubits to create just one reliable logical qubit for error correction. Companies like Google and IBM are developing more efficient QEC algorithms to reduce the number of required qubits, bringing quantum computing closer to real-world applications. Scalability. To achieve meaningful computational power, quantum computers need to scale up to millions of qubits. However, maintaining quantum coherence across such a vast number of qubits without interference is an enormous challenge. Scientists are working on modular quantum architectures, which allow multiple quantum processors to be interconnected, similar to how classical supercomputers operate. This approach could bypass current hardware limitations and enable large-scale quantum computing in the future. Operational challenges. Quantum computing faces significant operational bottlenecks, including extreme environmental conditions. Quantum processors require temperatures near absolute zero, 0 Kelvin or -273 degrees Celsius, to maintain superconductivity. Ultra-precise isolation. Even minor external disturbances, such as heat, pressure fluctuations, or electromagnetic interference, can cause quantum decoherence, rendering computations useless. The bottleneck in quantum computing. To achieve quantum supremacy, researchers must solve 3 critical issues. Qubit stability, ensuring qubits remain coherent long enough for complex calculations. Quantum error correction, developing efficient techniques to detect and fix errors in quantum systems. Advanced cryogenic cooling, enhancing refrigeration technology to maintain quantum processors at ultra-low temperatures. Classical supercomputers struggle with problems that involve combinatorial explosion, where the number of possible solutions grows exponentially, while quantum computers, leveraging superposition and entanglement, can evaluate n possible solutions simultaneously to find the optimal answer exponentially faster. Scientists believe that in the future, quantum computers could replace classical supercomputers for drug discovery, material science, and complex simulations. Proving the biggest puzzle result. When a quantum computer solves problems that classical computers cannot, how can we verify whether the result is correct or not? Suppose a quantum computer claims to have discovered the optimal molecular structure for a new drug, but classical computers cannot verify it. In this case, we need to develop independent verification methods or create self-verifying problems. Researchers are experimenting with using two different quantum computers to cross-check results or employing special algorithms to prove the correctness of the solution without having to solve the entire problem again. The future of quantum computing. It is predicted that within the next 5 to 10 years, we may achieve true quantum advantage for practical problems. However, building a fault-tolerant quantum computer could take another 20 to 30 years or even longer. We are still in the early stages of this exciting journey, filled with both immense potential and significant challenges. The dream of quantum computing is no longer just science fiction. It is gradually becoming a reality, unlocking breakthroughs in science, medicine, technology, and many other fields. Once we overcome these obstacles, quantum computers could help solve some of humanity's most complex problems, from drug discovery and supply chain optimization to revolutionizing data security. Wow! The journey into the world of quantum computing is truly fascinating, isn't it? We hope this video has given you a clear understanding of one of the most promising technologies of the future. The race to develop quantum computers is intensifying, not just because of their immense potential, but also due to the hidden risks they pose to data security, especially in finance and national security. The key issue lies in the superior decryption power of quantum computers. If quantum computing becomes widely available, existing encryption methods like RSA could become obsolete. When that happens, your Facebook, Zalo, and other online accounts could become a joke in the face of quantum computing's immense processing power. Banks and online transactions will face an unprecedented security threat, requiring stronger and more advanced encryption methods. That's why experts are racing to develop quantum-resistant encryption technologies to protect sensitive data from future threats. In our next video, we'll dive deeper into data security and explore next-generation encryption technologies designed to combat the quantum threat. Stay tuned. Thank you for watching until the end. Today's video ends here. Don't hesitate to leave a comment below to let me know if you liked this video. Please share the love and give it a thumb up, as well as hit the subscribe button so you never miss an update from us. Thanks for watching and see you soon. Bye-bye.